Hi, I'm going to do a short little video on Section 8.4, just a few extra examples in case you're having trouble with trigonometry. It's kind of a different type of section, and so I just thought it would be helpful if you had a few extra examples if you're having trouble just seeing the notes as your only examples. So I'm going to do a few of when I give you the angle and you're finding a side, and then I'm also going to give you some where I give you the sides and you're finding the angles. Okay, so as an example, these four, you are given an angle of a right triangle. That acute angle is not a special angle. It is not a 45, is not a 30, is not a 60. So when that happens, you have one choice, and that is trig. Trigonometry is going to be used because the ratios of the sides of right triangles, any triangle that has that 37-degree angle and that 90, the side ratios will all be proportional to each other because they would be similar. So that's why your calculator has these ratios stored in them. Okay, so if you look at the angle, I call it the reference angle, angle 37, and you mark it, you could use that one or this acute one. I'm going to use 37 because it's already there. And this is considered the side opposite, this is considered adjacent, and this is the hypotenuse. All right, now notice you have nothing on opposite, so you won't use that. This is the A and the H. So if you think about SOHCAHTOA's name, SOHCAHTOA is a little acronym we use to remember trigonometry ratios. So this is the A and the H, so you're going to be using the cosine ratio. So we abbreviate that cos, and then we look at the two letters, and that's A over H. So it has to be 11 over X. It can't be the other way around. Okay, now, oh, I forgot to put the angle measure in here. Cos of 37 equals 11 over X. All right, so then you're going to take your calculator and you're going to find the cosine of 37. You need to make sure you are in degrees so that you can get that 4-digit number correctly. This is the ratio the calculator has stored for any 37-degree angle in a right triangle. The A over the H has this ratio. 0.7986. So we're going to make this 0.7986 equals 11 over X. And then I like to make this a proportion. It just is easier for your brain to solve. So we're going to cross multiply. 0.7986x equals 11. And then you'll have to go back and divide by that 0.7986. That will always happen. If the variable is on the bottom, you'll always be taking that top number and dividing by the cosine or sine or tangent of whatever number you're using. So you're just going to type in 11 divided by 0.7986, and then you're going to round to the nearest tenth for the side. So this is going to be 13.8. So I'll just put here x equals 13.8. Okay, so now I'm going to go a little faster just to kind of show you a few more examples. This is our angle, reference angle 32. This is the opposite. This is the adjacent. That's the hypotenuse. We will not use the hypotenuse. It's an O and an A, so we go over here to SOHCAHTOA's name. The O and the A is the tangent ratio. So we're going to set this up as tan, then the angle degree, 32, equals O over A is X over 13. Then we're going to take our calculator and do tan of 32 and round to 4 decimals, 0.6249. 0.6249 equals X over 13. Then we're going to make this a proportion, and we're going to cross multiply. Now the good news is the variable's on the top, so you literally just need to take that decimal times 13. Since I already have it stored in my calculator, I'll just hit times 13, and I'll get 8.1 if I round to the nearest tenth. That is the measure of that side length. All right, next one. This is the opposite, and this is the adjacent, and that's the hypotenuse. Opposite's always across, adjacent's next to the angle, but not the hypotenuse. So again, we're not going to use the H, we're going to use the O and the A. So this is another tangent. So tan 50.1 equals, opposite is X over 5. Make this a proportion. So we're going to hit tan 50.1 and get 1.1959, so it'd be 1.1960. 1.1960. 4 decimal places you still need equals X over 5. You're going to just cross multiply, and again the variable's on top, so this is going to be where you just take that decimal and you take it times 5. So I leave it in the calculator times 5, and I'm going to get, when I go to the nearest tenth, it's going to need to be 6.0, so X is 6. All right, last one of these. This is a special triangle, so actually I could treat this as a 30, 60, 90. and take 11 and divide it by radical 3 to get x, but they've set this up as trig, so we're going to try it. Even though on your test you would never treat this as a trig problem, we'll just do it for the sake of practicing here. So 60 degrees, this is A and H, and so I'm going to look at A and H, and this is cosine again, so this is cos of 60 degrees equals x over 11. So the cos of 60 is 0.5. I can't round it to 4 decimals because it doesn't have 4 decimals, over 1. And then I'm going to take 0.5 times 11, which is just half of 11, and I'm going to get 5.5. So those are examples, more examples of how to find missing sides. Now I'm going to jump up here and give you 4 examples of how to find missing angles, which is inverse trig. So this is when you're going to use cosine -1, sine -1, and tangent -1. All right, so this is my angle I'm trying to find, my reference angle. This is the H, and this is the A, and this is the O. So we're not going to use the O. So again, the A and the H is cosine. So I'm going to say cosine of theta, which is like a variable on the x, or on the angle, and that's going to equal 13 over 12. Now to undo this, my theta will be the inverse cosine. So I'll do cosine -1 of 13 over 12. And that will undo the cosine, basically, and make you go backwards on the calculator. It's basically going to have the calculator pull up the angle degree using that ratio, since we know both of the sides. So the way you do this is you hit second cosine, and you look for cosine of -1, or you might have to hit trig and then arrow to the cosine of -1. And I usually do the division key because there are times where the calculator doesn't like the fraction key on these. So if you use the division key, well, didn't like that, did it? So let's see here. Oh, that's because I mislabeled. So let's go back here. This is the hypotenuse, and this is the adjacent. So I have this reciprocal. I have that wrong. It should be 12 over 13. So luckily the calculator showed me that I was doing it wrong. So now I'm going to hit second cosine, and I'm going to do 12 divided by 13, and again use the division key. So this is going to be about 22.6 degrees, and if it says round to the nearest tenth, then my theta will be 22.6 degrees. All right, for this one, this is my opposite and this is my adjacent, so that's going to be tangent. So I'm going to say tangent of some angle equals the opposite 4 over the adjacent 13. All right, to undo this, I'm going to hit inverse tangent and use that fraction to pull up the angle that's stored in the calculator. So I'm going to hit second tan 4 divided by 13 and get 17.1 degrees. So the theta angle is 17.1 degrees. You might notice that these are easier than the ones I did at the beginning because finding an angle is faster than actually finding a side, even though you're going backwards. All right, I'll do 2 more. So this is the angle I'm looking for. This is O, A, and H. So I'm going to use A and H, which is cosine, and we have not used sine yet. So cosine of theta is the A over the H, which is the 6 over 9. I want to undo the cosine, so theta will equal cosine of -1, 6 over 9. So some angle has that ratio in their cosine, so you're asking the calculator to pull it up. Second cosine, 6 divided by 9, is 48.2. So the theta angle is 48.2 degrees. Okay, so I'm looking for if any of these are sine, and A over H, and O over... Yep, none of these are sine. I don't know. They never did any sine questions. So we'll just do one more of these. So this is O over A. So again, it's tangent. So tangent of some angle is 11.9 over 10. So to undo it, I'm going to hit tan -1, 11.9 over 10. And that will help pull up the angle that has that ratio. So second tangent, 11.9 divided by 10. And I'm going to get 49.95. So I can't go to the nearest tenth there, so I'll have to go to 50. So the degree angle on this one is 50 degrees. And those are the 2 types of questions that we use in trig for section 8.4.